If you think the universe has already surrendered all its secrets to science, prepare yourself for a humbling shift in perspective. The cosmos is revealing truths that even the most seasoned astronomers never dared imagine, and at the heart of this revolution is a single instrument: the James Webb Space Telescope. With a precision unmatched in human history, it has begun dismantling some of our most cherished assumptions. Ancient galaxies, impossibly mature for their age, appear where only cosmic dawn should have been. Gigantic structures stretch across unimaginable distances, arranged with a symmetry that hints at something more than chance. And scattered among these marvels are anomalies, gravitational, structural, even rhythmic, that refuse to bow to the rules we thought we understood. When the first images arrived from James Webb, astonishment spread through the astronomical community. There, amid the faint glow of the newborn universe, were vast, bright, fully formed galaxies, shapes that should have taken billions of years to assemble, existing only a few 100 million years after the Big Bang. It was like planting a seed and finding a century-old oak by morning. These galaxies bore heavy elements, oxygen, iron, signatures of multiple generations of stars that had lived, died, and enriched their surroundings in record time. The standard model of cosmology, with its patient timelines and gradual growth, simply could not account for such a rush. By 2025, evidence had solidified. Galaxies 300 to 500 million years after the Big Bang were far more developed than our models allowed. Theories sprouted. Perhaps the early universe contained unusually dense pockets of matter. Perhaps dark matter's original distribution shaped these systems with surprising speed. Or perhaps forces unknown still lingered in those early eons. The debate deepened, with researchers even exploring radical possibilities like modified gravity or early dark energy. But galaxies were only part of the surprise. James Webb revealed something stranger still: structures on a cosmic scale, arranged in ways that almost seemed deliberate. Picture the universe not as a scattered spray of stars, but as a grand, three-dimensional tapestry. Galaxies linked together in colossal strands known as cosmic filaments. In 2023, Webb spotted one such filament, 10 galaxies aligned like pearls on a string, dating back to just 830 million years after the Big Bang. These filaments can stretch for hundreds of millions of light years, repeating in wave-like patterns, an architecture far too orderly to match earlier simulations. Surveys have since mapped nearly 2,000 galaxy groups across more than 12 billion years of history, showing that matter does not disperse at random, but follows an intricate design. This cosmic web influences everything from star formation to the movement of entire clusters. And yet, as scientists traced its strands, Webb uncovered distortions, places where light bent under gravity with no visible matter to cause it. One of the most striking examples came in September 2023. An Einstein ring, a perfect loop of light encircling a distant galaxy known as JWST ER1. The effect was caused by another galaxy in front of it, whose immense gravity bent the background light. The mass involved was staggering, 650 billion times that of our Sun, yet visible matter accounted for only a fraction of it. To explain the rest, scientists had to invoke far more dark matter than expected, and even then, its distribution made little sense. Other observations soon revealed similar distortions, suggesting that dark matter might not be as evenly spread or as well understood as we believed. Then came a phenomenon so strange it bordered on the uncanny. In early 2025, Webb detected rhythmic pulses of light every 29.437 seconds, precisely timed, emanating from patches of space where no visible source existed. The pulses continued for 37 minutes, then stopped entirely. Perhaps they were neutron star pulsars, scientists suggested, but the absence of visible matter in those regions made the explanation uneasy. Some theorized they could be fluctuations in spacetime itself. A few whispered of more intentional origins. The precision, the sudden silence, it felt like a signal though no one could yet say from whom or from what. These mysteries inspired new speculation about the very nature of the universe. Could it, as Sir Roger Penrose's theory of conformal cyclic cosmology suggests, be part of an infinite loop of births and deaths, with each cosmic eon leaving behind faint imprints in the next? Some patterns in the cosmic microwave background, noted in both Planck and Webb data, hinted at events from before our Big Bang. If true, the universe may carry a kind of gravitational memory, echoes from worlds long vanished, yet still influencing the present. And just when the focus seemed firmly on galaxies and theories, Webb turned its gaze to alien worlds. In September 2022, it captured the first direct image of an exoplanet, HIP 65426b, a gas giant between 6 and 12 times the mass of Jupiter. But this world orbited its star at an astonishing 92 times the Earth-Sun distance, far beyond where such planets are supposed to form. With no debris disk to explain its origin, scientists wondered if it had been hurled outward by unseen companions, or if we had misunderstood the birthplaces of giants entirely. Such enigmas inevitably provoke a more daring question. What if some cosmic structures are not the product of natural forces alone? Astronomers like Avi Loeb have entertained the possibility of astroengineering, civilizations advanced enough to manipulate matter on stellar or even galactic scales. Hypothetical constructs like Dyson spheres, designed to encircle a star and capture its energy, have even been tentatively hunted in Webb's data. Though none are confirmed, a handful of stars have displayed unusual infrared signatures that could hint at such feats. Curiously, the universe's structure may bear an unexpected kinship to something far closer to home, the human brain. In 2020, Franco Vazza and Alberto Felletti compared simulations of the cosmic web with microscopic images of brain tissue. Despite the difference in scale, billions of light-years versus centimeters, the resemblance was striking. In both, roughly 30% of mass clusters in dense nodes, while the rest forms thin connections. Both favor patterns that optimize communication and efficiency, and by 2025, further studies reinforced this idea. The principles shaping the brain's networks may be the same ones guiding the cosmos. These parallels feed into a growing suspicion that our physical laws may be only partial truths, simplified shadows of a deeper reality. The James Webb Space Telescope has shown us galaxies too old, structures too neat, and forces too mysterious for our current frameworks to handle. Modern physics, anchored in the Standard Model and general relativity, struggles with dark matter, dark energy, and the earliest moments after the Big Bang. Some now argue we must weave in entirely new concepts, information theory, memory, network complexity, into our cosmic models. Artificial intelligence is already helping sift the telescope's torrents of data, spotting patterns invisible to the human eye. A scientific revolution is stirring, one that might one day replace our current cosmology with something far richer, stranger, and truer. So we must ask, are we on the verge of truly understanding the universe, or have we merely glimpsed the tip of a cosmic iceberg, its vast hidden bulk still waiting in the dark? If the rules that govern reality are far different from what we've been taught, then we are living at the threshold of a new age of discovery, one where science itself may have to be rewritten. And for those following each new revelation from James Webb, history is unfolding in real time. What lies ahead may be even more astonishing.